All right, so let's talk about 6.5, logarithmic properties. So just like all of those exponent rules, logs have rules too, and they're the same because they're related. So if I were to, anything that has an argument of 1 is going to equal 0, always. Now, if we think about that, if we were to rewrite this, it would be a to the 0 equals 1, which is our exponent property, because anything to the 0 equals 1. So those rules go together. If your base and your argument are the same, they're going to cancel and equal k. If I were to rewrite that, it would be a to the k from this a and k equals a to the k, which is true. So that's kind of like the proof, but these will always cancel and leave the exponent. It works the same way in reverse. So if your base has the same of an exponent log, that's also going to equal k. If we were to put that in log form, we would say log base a, and then the answer becomes the argument, and it equals the exponent. So this yellow is just showing you, if we put the log form into the exponential form, how it matches. The properties are the ones I'm doing with the pink. All right. Now we're going to look at like our product rule and quotient rule. So with exponents, if you were multiplying things with the same base, you would add the exponents. So we're going to do the same thing with logs. This is multiplying. So we can break it apart by saying log base a of x plus log base a of y. So that multiplication tells us we can break it into an addition problem. That carries in. So if multiplication is addition, subtraction is going to be division. So the numerator minus the denominator. With a product rule, so with an exponent, power to power, you multiply. What really means is you can bring that exponent in front. So this is the same as saying r times log base a of x. So these 6 things are just rules. Those will be on the note sheet I give you for the exam, but they're just rules about logs that you can use to rewrite. So we're going to look at the first section here with the rewrite. We're going to expand or cancel things out based on those rules. So if we look at this first one, it's 8 times x. So because of this rule up here, we can break it into an addition problem. Log of 8 plus log of x. If we look at the next one, log base 9 of 15 over 7, that's division. So we can say log base 9 of 15 minus log base 9 of 7. Here, the next one is we want to get rid of that radical. We want it to be a number. So I'm going to rewrite that like an exponent. So anything to the square root is like saying an exponent of 1/2. Now we can use this rule to bring the 1/2 in front. So 1/2 times log 5 of 8. Now if we did the bottom, there's a couple ways you can think about this. You can think of 0.1 as 1/10. So that's true. So 0.1 is the same as 1/10. So one way you can do this one is make it a division problem. Log 1 minus log 10. The other way you can do this is you may go, oh, that's right. If something's on the bottom of a fraction, it has a negative exponent. And then you would bring the negative exponent in front. These both are going to give you the same thing if you plug them in the calculator. They're both going to equal -1. And that's because this log 10 of 10 is going to cancel. That's that rule. That's this rule here. But the idea, it's more about, can you figure out how to A, turn that into a fraction, and then B, one of those two things. They'll get you the same answer, so it doesn't matter which one you do. All right, let's go to the other side. Over here, we have a base of 2, and our log also has a base of 2. So that's all going to cancel, and it's just going to equal 3. That's this rule up here. All right. Okay, so now we're going to look at this. This has a fraction and multiplication. We're just going to do each piece. So that fraction is division, which tells us to subtract. So we're going to start by saying log base a of x minus. That takes care of this. Then I'm going to put the denominator in parentheses since there's 2 letters. In the bottom, we have multiplication. So in our extended thing over here, we're going to add. So we're going to say log base a of y plus log base a of z. And that's the expanded version. Right now, in this section, it's not super helpful. Like there's no practical. It's just going back and forth. Well, in the next section, you're going to use these properties to solve equations. All right, so if we look at the next one, this radical can be rewritten as a fraction exponent. So our base is m, and then the exponent becomes the numerator, the index becomes the denominator. So that's how you get rid of the radical symbol. And then we use the property where we can bring the exponent in front. So all 3 of those actually equal the same thing. All right. So this one, there's a lot of pieces. So we're going to do one piece at a time. The first piece is going to be to get rid of the radical. So we know it's log base b. All of this is inside the radical. So I'm going to keep that in parentheses. There is no exponent here, so it's a 1. And the base is an n. So the radical's gone. Now, I want to get that exponent away. So we're going to move it in front. So it's 1 over n log base b of this. Now we're going to break that fraction apart like we did up here on this one. So we're going to do each piece separate. So I'm going to go down below and break 1 over n log b. Put parentheses because that's all in parentheses. So on the top, we have x cubed times y to the 5th. So we're going to rewrite these as log x cubed plus log y to the 5th. And then subtract the denominator. So log b of z to the m. Now we technically can go one more step and get rid of each of those exponents. So the 1 over n is going to stay. We're going to bring this 3 in front. So 3 log base b of x plus 5 log base b of y minus m log base b of z. So that's as expanded as we can get that. Again, for the purposes of this, it's just practicing the rules. In the next section, we're going to use them. So now we're going to do the opposite. This one says combine. So we're going to take the spread out ones and rewrite them so there's only one log. So to start, this first one has all the parts have a log base c. Log base 3. So I'm going to write log 3. The plus tells us we're going to be multiplying. So x plus 2 times x. The minus tells us we're going to divide. So we're going to take that whole thing and put it over 2. You can distribute the x if you want, but that right there gives us what we need for the purposes of this question. It's just showing that you recognize the multiplication and the division. So let's look at the next one. Here, first we want to bring the numbers in to become exponents so that all we have is the log. So we move them up as exponents. Now we recognize that they're both log base A, and the minus tells us division. So we're going to do m squared over n cubed. Okay, same idea on this one. Don't let the fractions scare you. We're bringing each of these up. So log base b of m to the 1/2 plus log base b of 2n to the 3/2 minus log base b of m squared n. So now we have our log base b. Plus tells us multiply. So m to the 1/2 times 2n to the 3/2. The minus tells us divide, so over m squared n. If it just says combine, that's fine. If it wants you to simplify, we need to subtract our things with common denominators. So what we're going to do first is we're going to distribute this. So I'm going to ignore the log base b for a minute. I'll bring it back. So we have m to the 1/2 times 2 to the 3/2 times n to the 3/2 over m squared n. When we're dividing, we subtract exponents. So for the m, 1/2 minus 2 is negative 1/2. The 2 is going to stay. And then n, 3/2 minus 1 is 1/2. So if we put that back into a fraction, this is going to go on the bottom to make it positive. And then we can put everything in a root. So the 2 on the bottom of each of those fractions is actually going to be a square root. And then you'd have 2 cubed n over m. And we'll bring the log base b back. Now that one's a lot. Okay. So the big part is this. Can you get to this? That would be like 3 out of the 4 points. Then simplifying is distributing that exponent to each piece. That's how I got from the green to the red. So I distributed the exponent. Then we had a division problem, so I subtracted the exponents. Then I used the denominator to make a square root. If it was a 3 on the bottom, I would have put a little 3 there. So that's where all those pieces came from. All right, let's look at another one. So we want to get the logs. So we're going to move this and we're going to move this. So log base 2 of x squared plus log base 2 of x minus 1 to a 1/2 minus log base 2 of x plus 3 and then squared and to the 3rd. So that's the power to power. So we could, and I would, do this right now and have x plus 3 to the 6. Then you just have a few less things floating around. So I got that by saying 2 times 3. Okay. Now we're going to combine them. So we have log base 2 plus means multiply. So x squared times x minus 1 to the half. Minus means divide, so divided by x plus 3 to the 6th. And because these have pluses in there, I wouldn't do anything else. I wouldn't expand this. I wouldn't try to take the square root. I wouldn't try to do this to the 6th power. The only reason we did that here is because there was no adding and subtracting. As soon as you throw that in, it's complicated, and this would be an acceptable answer. All right, let's do one more. So this whole thing is times 4. So we know at the end we're going to have a 4th power. So I'm over here just going to do this. That's what that 4 is going to become, an exponent. Now I'm going to do each piece. So that 3 is going to go there. That's the only exponent. And then they all have log. So log base 10, x cubed, plus log base 10, x plus 5, minus log base 10, 2x plus 3. Remember, we don't have to write the 10, and so now we can combine them. So log x cubed plus means multiply, minus means divide. And then we have our 4th there. And just like the one above it, because there's the adding and subtracting, that's as far as we're going to go, and that's okay. We could distribute this to each thing if we wanted, but I would accept this as your answer. So it looks like a lot, but really what it is it's just using these 6 properties, which will be given to you on a note sheet, to either condense or extend the things you're writing. So that's 6-5.